In this tutorial, we'll design residential floor joist A that is shown on the solved examples page on the Construction Calc website. You can print that if you wish, but it's not required for the tutorial. For clearest viewing, I suggest the full screen mode of Windows Media Player. That selection can be made in the lower right corner of the player. To get started, open Excel and then open Probeam. Your screen should look like this. You can input general information in this area if you wish, but that is optional. For help and instructions, mouse over any red triangle and a pop-up note will occur giving you instruction for that input. Also at the bottom there's a help tab that has printable help notes. Now back to the design sheet. The first required input is span. The floor joist span that we're designing is 12 foot 3 inches, which is equivalent to 12.25 feet. Press enter or tab after each input. Now the allowable deflection, we can go with code minimums of L/360 for live load deflection and L/240 for total deflection, or input something different. We want this floor system to be stiffer than minimum, so we're going to go with L/480 and L/360. This floor joist has no cantilever, so that stays no. It is not sloped, so that stays at 0 and 12. The live load is a regular floor live load, and the load duration factor for that is 1, so we leave that as it is. Loads from continuous member, no. Add self-weight. In this case we're going to select no because the self-weight of the member will be added in the dead load that we put in below. Will there be loads other than uniform loads? And in the case of this floor joist, no, only uniform loads. Now we can input whether we are anticipating a pressure treated joist, which we're not, whether it will be used predominantly in wet conditions, it will not, and whether it will be used in high temperature conditions, and the answer to that is no as well. So those stay as defaulted. Now we move to the uniform load over the full length of member input. We select a row that says floor loads because we're designing a floor member. The live load for residential is 40. Dead load for a typical framed floor system is 15. If you don't know that, you can mouse over at the top of each column and typical live and dead loads will appear for you. Tributary width for joists and rafters is the center to center spacing. In this case we want 19.2 inch on center spacing, which is equal to 1.6 feet. Now we're done with our input. Let's calculate. And then we will look at the loading diagram and make sure that it looks correct. Our span is 12.25 and we can see that we have a uniform load on it. No point loads, partial loads, or any other different loads, just the uniform load that we input below. So that looks right. Now let's go down and look at the solutions. This part of the sheet shows all of the possible solutions for our span and our loading. We could either use a 2x something or perhaps an eye level product. Let's look at this 2x first. The floor joist will be working in concert with other floor joists, which allows it repetitive member credit, so we will select yes on that. And now we see that a 2x10 dug fir number 2 at 19.2 inches on center is acceptable. These other options are as well, but the 2x10 would be the most logical choice. Now in the eye level section, we see that a 9.5 inch TJI 110 is acceptable. We could stop now and build our floor with either of those types of materials, or we can go down and check the efficiency of those. Let's start with the 2x10. That's a sawn member. Let's pick it from the drop down. There it is, and we can see that it is selected here, and now we can see that this member makes it by 22.9%, and bending is the controlling factor for that. So it's plenty strong and would work very well. Now let's check the eye joists, and let's pick the 9.5 inch 110, and we can see that it even does better than the 2x10. It makes it by 32.2%. Deflection is the controlling criteria. Now we could print this and we would be done, and then move to the next member.